What are quadratic equation roots in real-world word problems? Imagine you're throwing a ball into the air or designing a new skateboard ramp. Have you ever wondered how to figure out the exact moments when the ball hits the ground or the ramp reaches a certain height? That's where quadratic equation roots come into play. They help us find specific values that satisfy real-world situations modeled by quadratic equations. Quadratic equations are equations of the form x squared plus bx plus c equals 0, where a, b, and c are numbers, and it is not 0. These equations graph as a U-shaped curve called a parabola. The roots of the quadratic are the points where this parabola crosses the x-axis. In practical terms, these roots tell us the values of the variable that make the equation true. For example, when you throw a ball upward, its height over time follows a quadratic pattern because of gravity. The roots in this case show the moments when the ball is at ground level, meaning when it hits the ground. If you know the height and time, you can set up a quadratic equation to find the exact time the ball reaches the ground. In manufacturing, roots can help determine dimensions that meet a specific area or volume. Say a company needs to create a rectangular frame with a certain area. By translating the problem into a quadratic equation, solving for the roots gives the possible lengths or widths that satisfy the area requirement. These roots tell us the exact measurements to use. Roots are also useful in physical scenarios like climbing or falling. If a climber's path is modeled with a quadratic equation, the roots can tell us the maximum height reached or the distance fallen. They help us understand the limits or key points in these situations. To find these roots, we can use different methods. Factoring works if the quadratic can be broken into simpler parts. Completing the square is another way, which involves rewriting the equation to make solving easier. The most common method is the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. The part under the square root, called the discriminant, tells us about the roots. If it is positive, there are 2 different real roots. If it is 0, the roots are the same, meaning the parabola just touches the x-axis at one point. If it is negative, the roots are complex numbers, which don't have a real-world meaning in most physical problems. In real-world problems, the roots often representing things like time, distance, or size. Sometimes, a root might be negative, which doesn't make sense for the problem. For example, a negative time or negative length isn't practical, so we ignore those roots. We focus on the roots that fit the context of the problem. By understanding how to find and interpret roots in quadratic equations, you can solve many everyday problems. Whether it's calculating when a ball hits the ground or designing a structure that fits a specific area, roots help turn abstract math into real solutions. They are the key to understanding the points where a quadratic model meets the real world.